Hi students, in this video we will discuss about differential relay. Such relay is operate when the difference of two electrical quantities exceeds a predetermined value. It is of two types, current differential relay and voltage differential relay. Now we will discuss about current differential relay. The meaning of current differential relay is when the difference of current is passes through the relay operating coil, then this relay is able to operate. Under normal operating condition, here is the figure. This relay represents for the protection. Here the relay is used for protection of alternator winding. The single line diagram of alternator winding is given here. The single line diagram of alternator winding is given here, and two similar rating of CTs are used in both sides of alternator winding. And a relay coil was connected in parallel with these two CT. Here we used 200:1 rated current transformer at both the end of alternator winding. Suppose under normal operating condition 1000 ampere of current was flowing through the alternator winding to the load circuit. Then this CT1 shows 5 ampere, means if 200 ampere current is flowing through the CT primary, then its secondary shows 1 ampere. Then in similar ways 1000 ampere current is flowing through the CT's primary winding, then it shows 1 by 200 1 by 200 into 1000 means 5 ampere. Under normal operating condition, this CT secondary shows 5 ampere reading, which is flowing in this way. Similarly, the CT2 having the same rating 200:1 ratio, the 1000 when the 1000 ampere current is flowing through this CT2 primary side, then its secondary side was also seen 5 ampere. So this 5 ampere current is flowing through in this direction, and the total amount of current is passes through in this way and close the path. The amount of current flowing through this relay operating coil is 0 ampere under normal operating condition. So this relay is not able to operate. But when fault occur, in this figure I represents the ground fault occur in the alternator winding. Suppose a ground fault occur in this alternator winding, then if 1000 ampere of current enter to the alternator winding, simply its 4/5 part was passes to the ground due to its shortest path. Its 4/5 means about almost 800 ampere current was passes to the ground due to its shortest path, and the rest amount of current means 200 ampere current was flowing to the load circuit. In this condition, the CT1 shows 5 ampere for 1000 ampere current flowing through this CT's primary side, whereas the CT2's secondary shows 1 ampere because 200 ampere current is flowing through the primary side of CT2, so it shows 1 ampere. In this circuit, 5 ampere current is flowing up to that node. After that, 1 ampere current is passes to CT2 in this direction and close the path, whereas the rest 4 ampere current is passes through this relay coil. So this relay coil is energized and the relay is able to operate, and the circuit breaker received a signal from the relay coil and separate the faulty section from the healthy section. But in this type of relay, one disadvantage is that if relay coil is very sensitive, then the small differential current flowing through the relay coil may cause it to operate under normal operating condition. Means, as there is a node present here, the very small amount of current is passes through this relay operating coil under normal operating condition, then it may be operate, but this is undesired for healthy section. So we are used a restraining coil to avoid these disadvantages. We are used a restraining coil in balanced beam relay where the amount of current flowing through this restraining coil is I1 plus I2 divided by 2, where I1 is the current showing in the CT1 secondary side, means the secondary side shows here is 5 ampere, plus I2 is the current showing by the CT2 secondary side, means 1 ampere divided by 2, means restraining coil the current flowing through the restraining coil is 3 ampere. This formula was derived in the note, and this PDF format was given in WhatsApp group. In this type of relay, the relay is operate only when the current flowing through the relay operating coil is greater than the current flowing through the restraining coil. When the current magnitude when the magnitude of current flowing through this restraining coil is less as compared to current flowing through the relay operating coil, then this relay is operate. If this example was taken into consideration, here the current flowing through the restraining coil is 3 ampere, whereas the current flowing through the relay operating coil is 4 ampere. So in this condition, in this fault condition, the relay is able to operate. But under normal operating condition, suppose very small amount of current is passes through relay operating coil, because at that node point there is also a branch through a relay operating coil. So if very small amount of current is passes through relay operating coil, then its magnitude is less as compared to current flowing through the restraining coil magnitude. So in that case, this relay is not able to operate, due to the condition is that this relay is able to operate only when the current current flowing through the relay operating coil is greater than the current flowing through the restraining coil. This is all about current differential relay. In the next video, we will discuss about voltage balanced differential relay. It was called, this relay is called current differential relay means the difference of current, that is the amount of current entered to the alternator winding and the amount of current giving away or outgoing from the alternator winding is different when the entering current and outgoing current through a alternator winding is different. This difference current is passes through the relay operating coil and the relay is able to operate. So it is called current differential relay. Thank you.